Hello, hope everybody can hear me.
Yep.
Good. My name's Steve North. I'm from EASE, the EASE Working Group at the University of Exeter. I hope you like horses because you're facing at least 18 minutes of them right now. I'm going to be doing two presentations. At the start off, I'm going to start off in a computer science mode, and then I'm going to head off in the direction of a bit more interaction design. I want to start by saying that if you'd like more technical information about this paper, the Salient Features paper, please look at the extended abstract. The video poster will also provide you with some interesting visuals from the process of developing and testing a horse detector. In this very brief talk, my approach is intended to complement both the abstract and the poster by describing the project in a more accessible manner. So, why horse detection? Well, my work is focused on animal-computer interaction with horses. I'm interested in using computer vision and machine learning to automatically identify horse behaviours. Automated identification of non-humans and recognising their behaviours are relevant topics in ACI because they, one, act as an interface between other animals and humans by interpreting the non-human's response to interactions and environments, and two, allow researchers to study non-human interactions with prototypes of ACI computer systems and devices, getting feedback in terms of the animal's stress, relaxation, frustration, etc. Automated identification of animals provides a key building block for applications such as tracking, automated behavior detection, and ubiquitous computing in animal housing environments. In turn, this may enable the development of more purposed systems for challenges such as automated feeding and enrichment. As part of my work, I collect video footage of free-roaming horses and domesticated horses in their fields. As part of the workflow of identifying behaviours, I've been looking at automatically summarising lengthy videos, often with sections with no horses present, down to short clips of horse activity. This led me to look at automatically detecting horses so that the sequences could be extracted from the videos. I quickly realised that detecting horses is surprisingly problematic. They are deformable, complex objects. Deformable means that they change shape a lot. Complex means that when they do change shape, there are lots of different shapes that they can form. Horses are also short of symmetrical viewpoints. In their 2016 paper on detecting horses, Udin and ACI, and the reference for this is in my extended abstract, note that detecting this species proves a particularly challenging problem because, quote, the size, colour and breeds are different. A horse is a non-rigid body. In other words, the shape and size of a horse varies greatly, and therefore the model of a horse is much more complex than that of rigid objects. Illumination and weather conditions vary greatly, unquote. Human animals are slightly easier to detect because our upright, two-legged posture reduces our complexity when viewed from different angles. In the world of computer vision, there are lots of example software detectors for humans and faces, which are fairly symmetrical, but not many for horses or other quadrupeds, not even horse faces, which would be relatively easy to detect. Just to be clear, the work presented here is not about behavior recognition, which is my main thing. I'm handling this at a later stage in the workflow using entirely different machine learning approaches. It's about creating helper applications for me and also addressing ways to optimize the detection of a deformable complex object, in this case, the horse. So, salient features, which is one of the focuses of this paper. Now, the more observant of you might notice that this is actually not a horse. What I'm trying to illustrate here is that lots of different species have salient features, and to be able to stand back and look at them, a silhouette is a good way to look for things that might be distinguishing or salient features. While I'm not going to talk to you about how software detection works, I should explain that I did find one existing horse detector, but it could only detect the bodies of right-facing horses, obviously a bit limited. In order to reliably identify horses on video in a variety of poses, I was facing the possibility of having to train, this is the name for teaching software how to recognize something, a detector for multiple different horse viewpoints. As training can take days or even weeks and thousands of example images, this was, to say the least, not very appealing. So I decided to look for a shortcut approach. I realized that if I could identify a horse feature that underwent limited change from different angles, then the morphology of the rest of the body was unimportant. So I looked for a salient feature, and this work represents my first attempt at this process. I chose horse ears. As you can see, horse ears are familiar from multiple viewpoints. This is my favourite model robot horse. They are a pair of vaguely vertical, long, thin, flattened oval shapes. They might be described as approximately parallel, but their presentation frequently resembles a V shape, with the separating distance closer at the base. A horse's ears are often, but not always, articulated in unison. They move about together because their functional anatomy and behavioural use determines it. If not in unison, their appearance following individual ear movement can still resemble a V shape when viewed from different sides. As the veterinary horse owner's textbook states, quote, each ear can be swiveled independently through 180 degrees or laid back, shutting it off. Such mobility is achieved with 16 auricular muscles attached to the base of the pinna. Humans have only 3 such muscles, all of which are vestigial. Easily visible at the top of the head, a horse's ears are used to signal emotional state and intent in response to directional sound. A horse flicks an ear towards the source, or if the sound is coming from the front, pricks both ears forward, unquote. So I selected horse ears as my salient feature, and I trained my software to identify them. Oops, jumped forward a few there, hang on. Sorry about that. Example horse images. To train the horse ear detector, I used 904 images, of which this is a subset that you're seeing on screen, just for example. There were 200 of these 904 were positive examples, containing clear views of horses with ears. 704 were negative images containing absolutely anything except horses. These could be random junk, or they could be photos of cars, buildings, people, etc., just random images. I've also released these 904 images as a data set, providing myself and others with a benchmark for future ear detection. This has a DOI and is freely available. You can see the reference in my extended abstract. At the end of the training process, an XML file is the final output. This is your detector. I then coded a very simple software application for testing the positive images, the ears, and the negative images, the not ears. The app could take one or more detectors, XML files, and test each image against them. At the end of processing, an output log file was automatically saved containing the results of the testing. So here you can see some examples of positive detections of ears. And as you can see, the horse detector worked. But I decided to increase its reliability by combining it with the existing third-party horse detector that I previously mentioned, the one for right-facing horses. So here are some examples of that detector working on its own, only able to detect right-facing horses. So when I combined my salient feature ear detector with the right-facing horse detector, I did get an improvement in detection when shown different pictures of horses in different positions, but I was frustrated by the limitations of only being able to detect right-facing horses with the added detector, as you can see in this slide. So I added in a new feature, which was image flipping to my detection software. So each image or video frame is now tested with a detector before being flipped and tested again. So what you're looking at here is actually 2 images, the top row and the bottom row. And I produced its image to check that the image flipping was working. I started with an image of the horse, then I flipped it around the y-axis and combined the 2 versions into one image. So I had an image of a mirrored horse. The top row shows what happened when the third-party detector for right-facing horses was applied, and this was only trained in that way, and you can see it could only spot the right-facing horse. The left-facing horse is ignored. In the bottom row, where the frame has been flipped as part of the detection process in my software, both horses are correctly identified. This was achieved without needing to retrain the detector for left-facing horses. Unfortunately, it's not possible. The way that the format for these XML detector files, you can't simply change a few references in the file and get it to work the other way around. It's so complex in terms of the machine learning process that that's just not possible. So you would have to train it to look at a left-facing horse. So the 3 approaches that I combined during this work were, just to refresh you, training a detector to recognize a species' salient features, combining my salient features detector with other existing detectors, and flipping images during detection to increase the efficiency of asymmetrically trained detectors. All of these improved the accuracy of detection when used in combination. And of course, training a detector salient feature speeds up the process of training software to detect species that have complex and changeable morphology like the horse. Unfortunately, this didn't produce a highly reliable detector. That wasn't really the point of this exercise. It's not ready to roll out and use, but it did suggest some quick changes that can improve detection and will feed into how I might go about improving that to get a more accurate detector. So now I have a slightly more reliable horse detector. It's still not great, but I could use it to cut lengthy video footage up into short clips that contain only horse interactions. And how I go about building this video summarizing software, that's another story, but it's one I'm going to save for the future. So thank you for your interest. That's the first of my 2 papers. I'm going to drop out of sharing screen for a second. And hopefully, I'm now hoping that I'm back with you. I am good. Okay, so are there any questions on that one? I'm hoping I can hear anything that's asked through the PA.
I've got a question if nobody else has. Steve, what do you see the application for this?
Well, as I said, I'm looking particularly ultimately at automatic identification of horse behaviours, and I'm working on that in other areas of machine learning. But this needing to rapidly detect them in video came to me because I was faced with huge quantities of footage from static cameras out in the field that were capturing, semi-feral, free-roaming horses, or just people's footage from their fields, and I wanted to capture every single behaviour. Now, traditionally, in ethology, people would look through the videos and do ethograms or logging. And I thought a first step to being able to do my automated detection is to chop the video up automatically into small sections showing only behaviours. And I mean, a refinement to this process at the moment, it's just chopping it up to, are there any horses in the scene? The next step is possibly you could customize it for energy level so that I would only start picking up on behaviors that were actually involved a certain level of movement that could be calibrated, rather than picking up every single movement, which might, you wouldn't necessarily want hours and hours of horses just grazing with very little movement either. So I would see it being refined, but ultimately it turns out my short clips of behavior videos, which then feed into the next part of my workflow for identification.
Great. Has anyone else got any questions? Or, well, I don't think I need to introduce you again, Steve. So.
Okay, no problems. Right, I'm going to go change presentation. It should be exciting. I'm putting it back into shared screens again for you.
Well, thank you for
yeah.
Okay, I'm hoping that's working now. Right, so I'm back again. So this one is going a little bit.
We can't see your screen yet. Sorry.
Oh, not come up yet. Hang on. Is that it? I think we've got it now.
Yeah. Thank you.
Brilliant. Good stuff. Okay, so this is moving away from the slightly more computer science focus, from the computer vision focus, and looking more at interaction design. And this is more slightly theoretical. It's also a bit playful. So I've called this Hey, Where's My Hey? Design Fictions in Horse-Computer Interaction. So I'm going to introduce you to this work. Horses and other animals are increasingly encountering systems designed by humans, as we know. Some of these systems are conceived with altruistic motives to enrich horses' lives. Other systems are designed to facilitate human interaction with little consideration for the animals forced to share the human environment. As with cognitively challenged humans, horses are unaware and often implicit interactors. This category of user is uniquely vulnerable to the projected requirements and needs of designers. By projected requirements, I mean the designer or the software developer actually wanting to, there's something they so much want to try out that they're not really thinking about the animal. To think like a horse or any user without a voice, a designer must be able to embrace the otherness of an unfamiliar perspective. The work described in my extended abstract and the video poster uses several examples of design fiction to speculate about systems that might actually be meaningful to a horse. The intention here is not to seriously propose these as prototypes. Rather, they are cautionary tales illustrating the inherent danger in trying to co-design with the voiceless, pointing out just how other non-humans may seem to the human animal. So, warning, this is a thought experiment. This is why I put the two big exclamation marks there. It's designed to be provocative and to make you think about things in an animal-centered way. But first things first, can you really imagine what it's like to be a horse, to see through their eyes, to live in a field with a herd of other horses, experiencing the weather and living in the moment? What would your priorities be? A good starting point is to consider the 5 needs that animals are entitled to expect from their human guardians under the UK's Government Animal Welfare Act 2006. These are 1, need for a suitable environment, 2, need for a suitable diet, 3, need to be able to exhibit normal behaviour patterns, 4, the need it has to be housed with or apart from other animals, and 5, the need to be protected from pain, suffering, injury and disease. And one might wonder how that's going to hold given what's going on at the moment with sentience and Brexit. Design fiction. So what is design or speculative fiction? It is writing, sketching, performing, or even one might say singing about a speculative situation and or artifact that may never exist in order to better understand the real design space in the here and now. This is very similar to the kind of things that you do in workshops and prototyping sessions and things. So this is a tool that could fit in there. It can be thought of as a design tool that stimulates and provokes outside-the-box solutions. So for this project, I sketched and specified several different design fictions, trying to imagine what it might actually be like to be a horse. Now, this is not about the quality of the sketching. This is just about me sitting in front of whiteboards and thinking of how it would be to a horse, what might be try to be important to them. And obviously, I'm not a horse, so I can't actually think like a horse, but I could try to imagine their priorities rather than thinking about the kind of things that might interest us. What would be great for them? What would they really want? The intention is not to present these designs as a serious reflections of equine requirement. Rather, it is to emphasise just how strange the priorities of a horse might appear to a human animal. To remind the human interface designer that their studies and emphasis must honestly reflect what the animal wants and needs. We will now look at some of the design fictions from my paper. So the current slide, this is Hey, Where's My Hay? Hacking the Active Stable. That's AKTIV. And this is where this short paper gets its name. The Active Stable is a real non-fictional computer-controlled housing and management environment for horses, which you can go and look up if you want. It provides resident horses with a limited daily allowance of fodder, that's hay or haylage. The automatic feed machine is controlled by a Wi-Fi connected computer running feed management software. Individual horses are identified by an RFID chip clipped to their mane hair. The system will deliver small, regular amounts of fodder to the horse via a conveyor belt system, up to a daily limit prescribed by the current horse. Now, in this particular scenario, I'm not going to go into the details of it, but they are in paper. The horse, who is called Blaze, you might notice on the left there, he was saying that he'd like to find some way to hack this system so that he could reset the daily allowance. And so by asking human programmers how it was constructed, he said, surely there's some way you can come up with a way where I tap my foot and it resets my day's allowance and I can get as fat as I want to. Okay, next one. So this second fiction is called Self-Carriage, the Autonomous Driving Horse Trailer. Our horse user would like to visit previous herd members and sites of special equine interest like historic grasslands, national parks, etc. He hasn't got a driving license. He'd like a system designed that would allow him to climb into a self-driving trailer, transport him automatically to his destination. And I can't see a problem with that. And in the final example, this is called Backs to the Wind Boys, a weather-responsive shelter for the British climate. Weather's a big thing with horses, and you'd probably find a lot of the things that they would want and need would relate to weather and food. Our fictional horse user and his herd have free access to a field shelter building. Our horse would like a shelter on a revolving pedestal, which is I've kind of highlighted here, which can easily be moved either by a motor or allowed to freewheel using the wind to control it. So it could be, for example, configured to stay always pointing in one direction away from the wind. The shelter will have 5 modes: wind avoid, hang on, I can highlight those 2, wind avoid, wind seek, sun track, shade track, and lock. Controlled by a nose touch interface panel sited inside the shelter. I know no one's ever going to build this, but you know, it might be exactly what the horse really wants. So we've had a quick look at design fictions for horse-computer interactions. I would suggest that a good starting point for putting oneself in the place of a non-human is to understand his or her ethology. That is to say, a species' natural repertoire of behaviours as displayed under natural conditions and shaped by evolutionary pressures. Therefore, it's useful for a designer to make him or herself aware of a non-human's typical behaviours as reflections of their underlying motivations. This provides a framework to begin hypothesizing the non-human partner's contribution to any process of co-design. For researchers and designers working in the field of ACI, design fiction is possibly something that we should all try before we get carried away with the ideas and gadgets that inspire and excite us. For the process to be truly authentic, we must honestly be doing this for the benefit of the non-human. Think about your target species. What do they want? What do they need? Can you truly see through their eyes? Thank you. So I don't know if anybody's got any questions.
Yeah, has anyone got any questions for Steve?
It's getting late in the day, isn't it? I can tell.
Oh, yeah, there's one.
Hi, Steve. That was really interesting. I loved it. The question it might seem a bit not necessarily related to your research, but do you ride?
So can you? Was the question? Do you ride?
Yeah,
Yeah.
that's.
Do you ride? Now that's a very interesting question. I have ridden in the past. I'm actually been vegan for about 6 months. Before that, I was vegetarian, and so I've been dealing very much with that as an issue now myself. How do I feel? Is this exploitation? Is it not exploitation? I actually enjoy just spending undemanding time with horses. I would never rule out riding as something that I would ever do again. And in fact, I have a young horse and I will be training him to accept the rider in a very gentle way, because I think that horses have to learn how to live in the human world. And if anything ever happened to me, I hate to think that he would not fit into the human world just because he had no idea about riding or leading or any of those things. So I teach him those things, but they're not the most important part of my relationship with any of my horses. I might sometimes in the summer go and sit on their backs, ride about bareback and bridleless for a few minutes. If a horse wants to go out, that's fine. Some horses love to go eventing and competing. Unfortunately, they're often not the horses who have the athletic build to make them desirable. So the horses that you see put into those competitive situations, I believe, are often not the ones who actually enjoy it, whereas there might be some fat cob who'd love to go running around a course.
Thank you very much.
Great.
That's a great answer.
Thank you. Okay.
Steve, thank you very much indeed. I think you're absolutely right about the ethology and how important that is. And I also like the bit you've just brought in now about taking in also the human aspect of how we perceive horses and any other animal too. So I just wanted to say thank you very much. I think it was a really nice talk.
Thank you. Was that Anne McBride speaking?
Yes.
I've got a message for you, Anne. I don't know
dear.
if you remember. From Colette Case in Belize. She says hello.
Ah, good. Thank you.
We do know each other from 27 years
We
ago.
do, absolutely. I recall that. Okay, thank you.
Great. Well, that was a brilliant talk, Steve, and we all
Thanks,
really
guys.
enjoyed it. Everyone's waving bye-bye. Oh, we got one more question from Sean Lawson.
Hey Steve, it's Sean. Is he gone?
Hello,
No, I'm here.
Steve.
I'm here. I'm just trying to listen.
Hi, Steve. It's Sean Lawson.
Hi, Sean.
You okay? So as someone else who's done kind of design fiction stuff around animals as well, we were always worried about kind of being very anthropomorphic about some of this stuff, and it's very difficult not to be. But in your own kind of design sketches, they're kind of quite human. In the way you're thinking about some of those things, were you conscious of that? Did you realise you were doing that? Did you ignore it, or did you just embrace that?
I think if I understood Sean correctly, I think was he saying that the sketches that I produced, they're actually somehow inherently human? Was that the basis of it?
Yeah, did you try and sort of personify an element of anthropomorphism into your sketches, and was it a bit tongue-in-cheek, I think, is the question?
I think, well, it is definitely tongue-in-cheek, but it's also trying to provoke people in all seriousness to take that on board and put themselves in that position. But, I mean, obviously, in reality, horses cannot express themselves through sketching, and so there had to be a human element, a layer on top of what I believed I knew about observing horses and their ethology. So, and to some extent, I'm trying to do the automatic writing on their behalf as some sort of communicator and channel for them. But it's very tongue-in-cheek in terms of its presentation, but the actual message underlying it is dead serious.
Great. I think there's. I don't think there's any more questions.
Great.
No?
Okay.
Well, thanks once more, Steve.
Thank you. Bye, everybody.